Hi, Urvija. Hello, Rahman. Good evening, Samajas. Hi, Sonak. How are you all? Guys, please turn on your camera.
All right, good to see you all. So would like to let you know about the setting in the demo. You all will be on mute, but in upcoming classes, you will be able to interact with your mentor freely, okay? So today, whatsoever you have to communicate and you want to ask, you have to just type it in the chat box and you have to use gestures, of course. All right. So anything we will be going to ask, are you clear? You're going to show thumbs up to us, right? Clear?
Very
All
good.
right. So type it in the chat box quickly. From which school and city you all are joining us? Mehmet, please turn on your camera as we don't allow students to sit with cameras off in our classes. And it will be
Okay,
good if
so
you just turn on your camera that we can interact face to face.
Urvija is joining us from Kota Bagh near Haldwani, and Samajas is from Hora, Delhi Public School. Okay. And what about Sonak and Rahman?
Sonak is typing. I can see his fingers are moving. Yeah, here we go with the answer.
Okay, Sonak is from RBK School, Mumbai. Okay, Urvija's school is S-
Swastian
Swastayan
Public
Public
School.
School.
Swastian Public School, Kota Bagh near Haldwani. Great.
Yeah.
Good to know that, Urvija. Urvija. All right. So I hope you all are excited for your demo. I'm very sure, right? And you all are having a different topics, right? In which you have built up your interest, right? So would like to know which is your favorite topic in science. Yes, all of you. Just type it in the chat box, which is your favorite topic. Meanwhile, you're answering our question. So would like to inform you the flow of the session as Megha ma'am will be going to share a few chat links shortly, wherein she'll be going to provide detail for the same. Then you'll be going to meet your mentor. And after that, moving ahead, we'll be going to have a look on the short PPT, wherein that PPT will be going to provide a information related to your course, scanning forward with the dashboard work. All right, which will be going to be provided by me. I hope you all are clear with the flow of the session. Oh my goodness. I guess we are in demo of grade 6, right?
Yeah.
Mega mom,
So
topics are pretty
Sonak,
heavy.
Sonak is thermodynamics, man.
Oh my gosh. Great. Good. Good to know that your interest is super strong. I think your mentor is noting everything on her mental tablet.
Yeah.
Great.
Okay, so Urvija's favorite topic is magnets and human body. All right.
Okay. Mehmed, maths. No, this is science. We are in science demo. Grade 6 science. All right. So Mega mom, I think we can move forward with the chat links.
Sure, ma'am. I guess my screen is visible to everyone, right?
Yes, it is, ma'am.
Okay. So kids, as you can see, the first link is about syllabus link. So for you know more about the syllabus, just click on this particular link. Payment can be made by using this particular link. So if you're not enrolling for this batch, just click on this particular link and enroll for this batch quickly. You can share your feedback by just clicking on this particular link. All the batch details will be on this particular link. In case of further queries, you can email us at support@olympiadsuccess.com or drop us a WhatsApp on these two particular numbers. So if you find any internet glitch having this video, so we are going live on Facebook. So you can just click on this link and you can see this video on Facebook itself. So this is all about chat links. I hope I'm clear to everyone. Show me thumbs up like this if I'm clear. Okay. Over to you,
Oh
Pooja
my
ma'am.
goodness, so many thumbs up Pooja has sent for
Over
the
to you.
confirmation. All right, thank you so much, Megha ma'am. And I would like to move ahead with the mentor now. So the mentor is already here with us. Her name is Miss Sakshi. She is a wonderful mentor. Her classes are very engaging and interactive and interesting for sure. And I hope that you'll be going to enjoy your demo as well as this demo will be going to be very productive for you, right? So all over to you, Sakshi ma'am.
Good evening, students. How are you all? Fine. How are you all? Okay, so I'll be teaching you science, and I hope our interaction would be very productive and we'll have a great time together from today onwards. So you can share your gestures, you can share your thoughts in the chat box, and also from the next class, you can unmute yourself and speak as well. You can raise your doubts, you can ask whatever you want to. Okay. But today, as we have demo, so you can respond by your gestures. And I would appreciate if you would participate to the maximum, right? Okay, so are you all excited for the demo today? Just give me a thumbs up if you are. Okay, I just want to see how many are excited. Okay. What about Sonak? Okay. Okay, that's great. That's great to see. Yeah, ma'am, should I start or?
No, first we'll be going to show them a demo PPT, ma'am.
Yeah.
So, Megha ma'am, can we have a PPT on the screen, please? Good, Sonak. Good to know that you prefer to do it manually. Very nice.
Hope my screen is visible.
Yes, your screen is visible, ma'am, but you're not audible.
Am I audible now?
Yes, you are now.
All right. Okay, kids. So I welcome you all on the platform of Olympiad Success. So this is the demo interaction program for grade 6, and the subject is science. So Olympiad Success is the largest online preparation platform for Olympiad examinations. We are the India's first exclusive live classes for Olympiad preparation, one of its kind, that yearly program that matters. We have 8 courses like mathematics, English, science, logical reasoning, communication, spoken and written, Vedic maths, and coding. What else we provide? We provide one-on-one online CBSE, ICSE, IGCSE, and IB classes from grade 2 to grade 12. One-on-one preparation classes for International Mathematics Olympiad, SASMO, CMO, HKIMO, TIMO, Maths Counts, US Common Core Maths Competition, Maths Kangaroo, and PRMO. So these are the kids like you. These are the rank holders. These are the kids like you only. So for if you want that your picture should be here, then what you just need? You just need 2 hour extra from your regular curriculum, because Olympiad examination is little tougher than the regular curriculum. So Olympiad sessions have group sessions with around 20 students delivered through Zoom by tutors with significant teaching experience, having 3 sessions per week, Tuesday, Thursday, and Saturday from 8 p.m. to 9:15 p.m. with 5 minutes of breaks. This session includes a mix of theory, practice question, doubt sessions, and discussions on previous year papers. Students will getting reading material and practice question available on the dashboard of Olympiad Success, and you will get free access to Olympiad Success platform to practice the topic-wise mock test for having 10 to 15% of maths and logical reasoning. Subjects syllabus is available on on this particular link, and the fee of this course is rupees 10,036 rupees. Having 40 session course, payment can be made by using this link. The fees includes online classes, daily reading notes and exercise, practice of previous year papers, and access of Olympiad Success platform for mathematics and logical reasoning both. What you all require: a laptop or desktop with good internet, a laptop with better clarity of picture, and headphones of better audio clarity. So for the preparation of Olympiad examination is quite tougher than the regular school curriculum. So you just cope up with 2 hour extra from your regular curriculum. And the live classes will be started from 23rd of August 2024, which is on Friday. All right. So in 2023-24, Olympiad Success had students more than 5,000 schools across India and abroad. So this is all about informative PPT. I hope I'm clear to each and everyone. So if you have any doubt, you just write it in the chat box, or if you have no doubts, just show me thumbs up like this. Okay, over to you, Pooja ma'am.
Thank you so much, ma'am. Just a moment, and then we are good to go with our screen sharing. All right, so here we go. I hope my screen is visible to everybody. So this is our platform, students, wherein you have to just enter the URL olympiadsuccess.com and you'll get this page on your screen, wherein you have to just enter your correct user details. These are those details with which you will enroll for particular batch. All right. So after logging in, you'll get your personal details on your screen. In case you find any error, you can just rectify it over here and you can click on update button for the same. After that, click on live classes, select your subject and topic. For that, you'll get your specific material on your screen. Here you can see that everything is systematically designed for you, for your reference. Here's a schedule. You'll get to know in schedule that in which session you're going to have a specific topic, holiday calendar for holidays, reading materials, practice question papers, and answer keys. So you can see after completion of every chapter, there are test discussion sessions also, that in case whatsoever you have find difficulty in the chapter while attempting your test, you can just clear it from your mentor, right? So at the end, you will be getting a super classes also. In that super classes, you'll be going to practice previous year papers. So that is a one more practice sessions for you, right? So you can see each and every chapter is bifurcated in different sessions, so that you can grab a detailed knowledge of each and every specific topic. So here is a holiday calendar, right? Now you can see your material. So I'll be going to show you set one. So each and every PDF is downloadable. You can just click it over here and you can download and you can keep it saved in your device, right? So you can just see the material. You can see the chapters, each and every topic, subtopics are crafted in detail, that you should not miss any of one particular sentence or phrase that you can say, right? So there's a complete detailed knowledge of particular topics. So here are the question papers also for your practice, along with the answer keys, but I recommend you to just download the paper first, take out the printout, solve it, and then check your answer keys. So you can see the questions are crafted at the level of Olympiad examinations. So these are our special design papers for you all, for your practice. So here is the answer key for particular question paper. Right? So you can see the best part in our platform is that while attempting the question paper, parallelly you're getting your answers. There's no time gap in between that you need to wait that how I performed or whatsoever it is. So you're getting it parallelly. So here are the worksheets which will be going to give you more practice, right? So for that, you have to just click on worksheet, select your subject and talk. Click on take exam. You'll get your instructions on your screen, read it, select this icon and start worksheet. So there are so many questions for you. So let's say I've done the question one, moving on next question. So I'll be going to click on next button. Let's say I have doubt in second question. So I can mark this question for review. Before submitting my worksheet, I can review it once again, right? So by chance, the wrong answer will not be submitted. So let's say I have done all my questions. I want to submit my worksheet. So the moment I'll be going to click on finish button, this icon will pop up on the screen, right? So now let me check once again. Yes, I'll be going to fill my correct answer and then I'll be going to submit my worksheet. Yes, I reviewed all the questions and I'm good to go to check my performance. So parallelly here also you can check your performance, that how you have attempted your worksheet. Select your subject. Okay. Yes, here you can see I have submitted this worksheet just now. You can click on view button. And here you can see the performance. I've attempted 3 questions wherein 1 is correct, 2 are wrong, right? So make sure whenever you're attempting your worksheet, you should be attentive properly and you should be having a detailed knowledge of your topic. So that's all about your dashboard. If anybody is having any doubt related to your dashboard or course, drop it in the chat box. We'll be happy to answer your queries. Everybody is clear? Nobody is having any doubt? Show me a thumbs up on the screen. All right. So now I have one question for you. Quickly type in the chat box. What are your class days and timings? And when your batch is going to start? Correct. It's Tuesday, Thursday, and Saturday. And what are your class timings? Absolutely correct. Guruja. It's 8 to 9:15 p.m. I think we are good to go then with the demo. I hope you're ready to rock the poster, right? All right, Sakshi ma'am, all over to you.
Okay, thank you, ma'am. Yeah. So hi once again. Okay. So should we start with the demo, students? Okay. Yeah, so you can see that there are so many objects around you. There can be some solids, there can be some liquids, and there can be gases. Are there any gases around you? Do you think there are gases around you? Oh, straightforward. Sonak has typed plasma. Okay, so there are different objects. You know, all the objects, all the different objects have mass. What do you think? Do they have mass? You have to type continuously, okay, in the chat box, whatever is there in your mind. I want answers in the chat box, okay? And I want your full attention. Urvija, Samajas, Sonak, Muhammad, yeah. So what do you think? Do they have mass or they occupy space? Yes. You have to reply to what I'm asking first. Yeah. They have mass and they occupy space. And that's why we call them cell or matter. What do we call them? The objects that have mass and occupy the space. Yes, very good. What we call them? We call them matter. So matter are something that have mass and occupy the space. So when I'm talking about matter, what do you think? Like, are there different states of matter? Is matter present in different forms? Or are all the matter same? Same or different? Just tell me that. I will see that who will participate to the maximum. Then I'll give an appreciation to that student in the end. Different. So they have different. So why I'm calling them different? What is the reason that I'm calling them that they are different? Because they are present in different states. There are different states of the matter. Can you see my screen? Yeah. So there are different states of the matter. So talking about the states, matter can be present in the 5 states. We are very familiar with the 3 states, right? One is solid, second one is liquid, and the third one is gases. So my question to you is, what is this? This is an earth, right? Is this an earth? What is so precious about earth? Like you can see green color, blue color, white color. What is so precious? Why the color of earth is shown in 3 different? Why earth is shown in 3 different colors? White color means what is present? Yeah. Green means greenery is there. Mountains are there, and you know that clouds are formed by evaporation, right? So they are a form of gases. So next we have solids also. Do you think that rocks are solids or the plants are solids? What do you think? Yes or no? And the liquids, why it's blue in color? Because there are different water bodies, there are oceans, there are rivers, there are lakes, ponds, streams, different, right? So liquid is also present. Water, earth is a planet that supports vegetation, that supports water, that has life. That's why life is possible, right? So when I'm talking about matter, so these are the different matter that has been found on earth, and they occupy the space and they have a mass. So when we are talking about the states of matter, students, so these are the different states of matter: solid, second one is liquid, third one is gas, fourth one is plasma, and the fifth one is Bose-Einstein condensate. Just let me know, have you heard about these additional two states? Have you heard about them? Bose-Einstein condensate and plasma? Let me check the chat box. Like, what are you replying? Like, have you heard? Or Vijay saying yes? Sonak, Samajas, yeah. No. Okay, Samajas is saying no. Okay, Sonak. Yeah. So, solid, liquid, and gases. You have to tell me what are the different. Okay, I'm just assigning one by one. Samajas will tell me any 5 solids around him. Urvija would be telling me any 3 liquids, okay, that are coming in her mind. And Sonak will tell me 3 gases. And Muhammad will tell me any 5 solids. Let me see that who will respond fast. Yeah. I'm waiting. So students, solids have a definite shape, right? Like if you can see the particles here, we all know that the smallest unit of our body, the smallest thing that our body is made up of is called a cell. Do we call it cell? Right? So the smallest thing that a matter is made up of, what do we call to them? We call it, what do we call it? Atom. So atom is the smallest particle of matter, right? So if I have to talk about the arrangement of atoms in solid, liquids, and gases, you can see clearly. Can you see it? That particles are closely packed in this first case, and in second case, particles have some sort of freedom to move. And in the gases, the particles are far apart. They have full freedom to move. They move in all directions. So in solids, the particles have a very tight arrangement, very rigid arrangement. That's why when you touch the solids, they are rigid. So when I'm talking about liquid, students, then liquids means the particles have some freedom more than the solids, but not that much. Like they can move, the particles can move. They have a definite volume. What they have a definite volume, but no definite shape. But no definite shape. They take the shape of the container, right? Let's suppose Sonak has put a water in the water bottle. Then he all in size. So would the shape changes? Would the water take the shape of the container? Yes or no? Yes or no? Urvija, Samajas, Sonak. Yeah. Muhammad. Muhammad, are you active? Are you able to hear me properly? Muhammad? Just give me a thumbs up if you can hear me properly. Yes, Muhammad? So when I'm talking about solids, so solids are rigid forces of attraction, like they have attract particles are holding to each other very strongly in case of solids. But when I'm talking about liquids, like you can see that there are some spaces between the particles. The interparticle spaces are there. The intermolecular forces are strong, but not that as of solids. So in case of gases, the intermolecular forces are weak. What Urvija is talking? With whom is she talking? Urvija? States of matter depend on pressure and temperature: juice, water, petrol. Oxygen, helium, argon, okay. Box, bottle, soil, plastic, rock. So all these, okay, just pay attention over here. Yeah, there is smaller than atoms. Atoms are divided into subatomic particles. Like if we further divide an atom, then we will get subatomic particles. Like we will get positive ions, we will get negative ions, and we will get some neutral ions, right? So when I'm talking about positive, like positive ones are called protons, negative ones are called electrons, and neutrals have no charge on them. Like we can also divide atom further. Okay, students, so like solids have a definite arrangement, liquids don't have, and gases, they can move freely. You know, when a gas leak occurs, when gas from a cylinder leaks out, so what happened in that scenario? Would it spread fast or slow? What is the rate of spread? Would it spread very fast or slow? Like you all know that CNG cylinders are there, LPG cylinder, LPG gas is stored in the cylinders. Even there are gas vehicles also that are not preferred, although, but yeah. And you know, the smell of perfume. What about the smell of perfume? Would it spread fast or slow? Would it spread fast or slow? Fast. Okay. And what about an incense stick that is put at the corner while doing any spiritual activity, like the smell of an incense stick? And even when we just see that a mother is cooking hot sizzling food, then we immediately get the smell of that. And what is the reason? When we are super hungry, we just feel, oh, something delicious our mother is cooking. So what is that? These are the vapors, these are the gas particles that comes to us. Okay, so the fourth one, we have plasma. You know, when we further heat up the gaseous particles, then a super energetic state is formed with the super energetic particles. And what do we call them? We call them plasma. What do we call them? Plasma. So when we cool something, to a very low temperature, when we cool it down, then this Bose-Einstein condensate is formed. So this is also a state of matter. So these are the different states of matter. So next we have, see this. So students, this is one thing, that matter can change the states. Like solid can be changed into liquid, liquid can be changed into gas, and gas can also be changed into solid as well. Let's suppose if you have solid, let's take an example of an ice. Okay, when you pass heat to the ice, what will happen? Would ice melt? Tell me. Yes. Yes. So ice would melt into liquid or gas? Yes. Ice would melt into liquid, or we can say water. And when we further heat this water, what would be formed? When we heat the water again, like initially you just place the ice cubes out of the refrigerator and it melts down because the outside temperature is high as compared to inside temperature, right? And when we further heat the liquid up, so what would happen? So what would be formed? Gas would be formed, the vapors would be formed. You must have seen the vapors that are attached to the hot plate of boiled milk. So those are the vapors that are attached. So, matter keeps on changing the state. As you can see this at the right side, the diagram to the right side. So heat is being passed. Heat is passed. And what would happen? What is this bluish thing that is ejaculating? What is that? This bluish thing. What is it? It's... Urvija, my screen is not visible. Is my screen not visible to all? Urvija, is it not visible right now? It is visible. Urvija, can you see my screen? If you can't see, then you can rejoin again. You can rejoin again. Yeah. So these are the changing states of matter, students. You must have heard about the water cycle process, the process of water cycle. So, there are different water bodies. Different water bodies, when sun rays fall on those water bodies, so what happens is the water from the rivers, the water from the oceans, they heat up, water heat up and it evaporates to form the clouds. So that is the transfer of liquid into the gas, and that is called a vapors. So that is an example of natural cycle where the states are changing. The states of matter is changing, right? Yeah, Sonak, what doubt you have, you can type. You can type. What doubt you have? If I want to turn water into Bose-Einstein condensate, how much negative temperature will I require? See, it depends on the state, Sonak. There is not an accurate estimation, but yeah, it must be negative. It must be negative, and you know, you just need to experiment that, like how much you cool that liquid so that you can form Bose-Einstein condensate. So it must be, it sometimes it must be at -20, sometimes it must be at -37. So it's like it's not fixed. There's no fixed value. Like when I'm talking about Bose-Einstein, condensate. What is the meaning of condensate? Yes, just tell me. You know the melting point of ice. Melting point. What is the melting point of? Yeah, it's 0 degrees Celsius, right? So if I have to talk about 0 degrees Celsius, so what is the temperature? Freezing. Freezing and melting points. 0 degrees Celsius is equals to 273.15 Kelvin, right? So if Sonak, you have to look at the Bose-Einstein condensate, that is formed beyond this, sometimes at this temperature and beyond it. You know, even lesser than this, in negative. Because there is an absolute temperature, like it can vary, it can go less than this, and it can be at 273 also, 273.15. Is it clear? Degree Celsius, which is equals to 0 Kelvin. And if you want to convert Kelvin into Celsius, what you need to do, you just have to add 273.15. Getting this, Sonak? Yeah, 0 degree. 0 Kelvin. 0 Kelvin would be equal to this much. Because if you want to convert Kelvin into Celsius, so you have to add 273.15 degrees Celsius. Whatever is there in Kelvin, you have to add this much temperature into it to convert it into Celsius. Okay, Samajas, is it understood? Urvija has just joined. And what about Muhammad? Muhammad is not responding. I don't know the reason. Maybe he's facing some issues of network. Urvija, is everything clear to you? Can you see the board now? Okay, so you can see the changing states of matter. Your videos should be on, students, because I want to interact with you. So videos should be super on. Yeah, Samajas, Sonak. Yeah, Samajas, Sonak. Samajas, why your video is off? So you can see here, when you pass the energy to the solid, they will change into liquids. Yeah, now it's on. Why you kept it off, Samajas? I have been noticing it from past 10 minutes that your video is off. Why so? Although you were responding good, but still your video was off. Were you doing something else with the classroom? Yes or no? I just want to know the answer. Okay, you forgot to turn on. Okay, so solids, when you heat the solids, when you add the energy, they will change to liquids. And when you pass the energy or heat the liquids, they will change into gases. And when you provide more energy, the particles of gases, they will start ionizing. When you supply energy to the gaseous particles, they will get that energy, they will absorb that energy, and Alina Sivach. Who is she? Hello, Alina. Hello. Alina, can you please turn on your video? Oh, she left. Yeah. So when you supply energy to the liquids, then they would change into gases, and there's a change in phases. As you can see here, the phases keep on changing. Like, see, when solid melt to form liquids, right? And liquid, when you pass the heat to the liquids, they will form the gases. So, do you know something about the boiling point? What is the boiling point? What is the value of it? I'll give you option 0 degrees Celsius or 100 degrees Celsius. What is the boiling point? And what about 0 degrees Celsius? Yeah, it's 100. Yeah, Sonak, it's ionization. It is the process of ionizing the gases. Freezing. 100 degrees Celsius is a boiling? Yeah. And 0 degrees Celsius is a freezing point. So this is what we have for these particles. Next, students, see this one. So there are processes that are involved. Let's suppose if solid is changed into a liquid, so that process is called melting, or you can call it fusion as well. Like you can take the example of an ice cube melting into water, right? That is called the melting of a solid. Ice cube melting into water, ice cream melting into water, chocolate melting into chocolate shake or liquid form. So that is called fusion, or that is also called melting. Then change of a liquid into reverse, okay? I'm doing the reverse of it. So the change of a liquid to solid. How can you convert liquid back to the solid? How can you convert? Like how can you convert any liquid back to the solid? Obviously, you can keep it in refrigerator, right? You can freeze it. You can freeze that liquid to convert it back into solid. Yes, right, right. Good. So next we have liquid to a gas. I gave you a very good example of evaporation process. And even you can take many more examples, like you can take the example of bubbles forming in a frying pan when you supply heat, right? You can see the boiling milk, that how vapors are formed in the boiling milk. Under the plate, there are vapors that are formed. So that is what we call evaporation also, the conversion of a liquid to a gas. So that is evaporation. And the reverse of it, changing of a gas into a liquid. You know, students, let's suppose vapors go up in the sky, right? So in the sky, they face low temperature. The temperature goes low. So when the temperature goes low, what would be formed with the vapors? What would be formed with the vapors? Like once a vapor evaporate, when they approach towards the sky, there the temperature was low. So what would be formed? So ice, okay, they will condense. Ice would be formed. Students are answering condense. They will condense. Yes. Have you seen the water droplets under the plate of a boiled milk? Have you seen, like after boiling, the water droplets are popped up like under the plate? What are those? Is that condensation? Would you call it condensation? Or what? Yes, that is condensation. Who else is answering yes? Who else is answering yes? Let me just check out. Is there anyone who is saying no? Yeah. So when we are talking about, yes, nice. So when we are talking about conversion of a solid into a gas, the conversion of solid direct to a gas, that is called sublimation. Have you seen the naphthalene balls, the white balls that we put it in the beds for storing the clothes? Those are white in color, right? But after some time, they just hide away. You don't see them. Where are they lost? Where are those naphthalene balls lost? Are they converted into gases or escaped? And what about that camphor? Camphor that we use for holy purposes, the camphor. Like when we supply heat to the camphor, you know, when we supply heat to the camphor, then straightforward it will convert it into a gas. So the conversion of a solid directly to the gas, that is called sublimation. What we call to it? Sublimation. And the reverse of it is called deposition. The conversion of a gas to a solid. Can you give me any example of conversion of a gas to a solid? Any example? Yeah? Any example where gas is being converted into solid? Just try, maybe you would be right. Yeah? Deposition example. Frost. Have you seen frost? Frost. That is a conversion of a gas to a solid only. What other examples can you give? Conversion of a gas to a solid. Who is this Eliana Sivach? May I know? Eliana, you have joined very late. Why so? Like you have joined almost at the completion time of the demo. May I know why are you late? You can type in the chat box. As we have been conducting this from past 40 minutes. Ma'am, there was a network issue. Oh, okay. So it was a huge one. Eliana? Yeah, so just let me tell you, Eliana, I would be your science mentor. You missed so many things, although, but it's okay if you managed to join. That's really nice of you. That after that, you have been constantly trying. So, Eliana, we are conducting a demo on the topic that is matter, right? So, we have reached midway to the session, almost at the end. You can continue from here, right? And whatever you know, whatever you want to know, the introduction thing and everything, that you can see in the recording if you would join. Okay, Liana? Yeah. So students, see this, like you can see the conversions, that how solid to a liquid. Is it clear to you? Liquid to a solid. So all these things. And deposition, I gave you the example of a frost. Frost, you know that frost is a form of gas, like frost is being attached to different items, even in winter season. So that is deposition, the conversion of a gas to a solid. And even, have you seen soot? Soot. What is that soot called? Unburnt particles, like the particles that make the utensils black, that are being attached to the utensils. So that are actually conversion of a gas to solid only. Like when you heat different substances, let's suppose uh, yellow flame is getting out from your gas and you put a plate on the pan, right? So you are actually supplying a gas. But after some time, you have observed that there are black fumes. There are blackness under the pan. So what is that actually? Is it a soot? Is it a soot? We call it soot. Soot are the unburnt particles. So that is an example of deposition. What do we call them? Deposition. So see here, students. I'll just recall you again. Like you can see, the conversion of a solid into liquid is called melting. Like conversion of ice cubes into water. Conversion of a liquid back into a solid is again called freezing. Like you can freeze something again by lowering down the temperature, right? The conversion of a liquid into gas. Ilyana, can you give any example of it? Conversion of a liquid into a gas. That how can liquids be converted into a gas? There's a one important process. Sonak is very active and I'm liking that. Others were facing some network issues because that's why they left 5 or 10 minutes ago. So vaporization is liquid into a gas. Condensation is gas into a liquid conversion. And plasma is formed when we heat the gas particles. When we heat the particles of a gas, then a new state is formed, and that new state is called plasma. Okay, the super high energetic particles are formed when you heat the gases, because the particles of a gases ionize. Okay, and when they ionize, they will form a new state. Is it clear to you? Yeah. Now see the next one, students. See the matter now. Matter is divided into two types. One is mixture, yeah, and one is pure substance. Mixture means mixing of two or three things, and pure substance means that is made up of one type of particles. Okay, just let me know what do you mean by pure substance? Like which things according to you are pure? Just type in the chat box. Just type in the chat box. According to you, which food items are considered pure? Is there any item that is pure? Okay, so what are you typing? Sonak, we have to learn this derivation. No, you don't need to learn anything. Orange one. Which one are you saying? No, you don't need to learn anything, Sonak. You just have to understand everything. Pure substance, yeah. So when I'm talking about pure substance, yeah, derivations are not required. You just need to remember like what are the different compounds and what are the different elements. Like you can see here that matter is divided into two types. First, mixture. Second, pure substance. Now, what are the mixtures? Mixture can be heterogeneous and homogeneous. What do you mean by hetero? Hetero means different. Hetero means different. A mixture that is formed by blending different particles, and where the particles are not blended with each other, like sand in water, like sand in water, like what else? Chalk in water. Heterogeneous means different, like that cannot be mixed properly, right? So homo means same. Homogeneous mixture would be formed when particles can be blended with each other, like sugar in water, salt in water, honey in water. So that is an example of homogeneous mixture. So mixture can be divided into two types. One is hetero and the other one is homo. And pure substance can be divided into two types. One is a compound and the other one is element. Element cannot be separated. It cannot be separated. So pure substances cannot be separated physically, but yeah, mixtures can be separated. Can you name any two or three mixtures that are coming in your mind? Two or three mixtures like that are formed by mixing different. You must have eaten that jaggery, desi ghee, and chapati by blending all these three things. Have you eaten some? Have you eaten before? Have you eaten it before? That is also a mixture because it is formed by mixing different components, right? Is it so? Are there any other mixture which you have tried? Mixtures. I want to know. Compound, yeah. Compound, Sonak. Compound means, right, that is made by combining different atoms and molecules. Compound means like water, like CO2 carbon dioxide, like acid, nitric acid, HNO3, like sulfuric acid, that is very strong acid. So compound means that is formed by combining different atoms and molecules. That is called a compound. Compound is a complex thing, right? So when it's a complex thing, then that would be made by joining different atoms. Like you can see, it is formed by joining hydrogen with oxygen. And here it is formed by combining carbon with oxygen. And here 3 different atoms are involved. So as the name suggests, compound is something that, that is made and a molecule, atom, and any other atom. So that is formed by a blend of these substances. So that is called a compound. So when I'm talking about an element, Sonak, you have asked the doubt. So element is something that is formed by same atom. Element, same atoms. Like hydrogen, when combined with hydrogen atom, it will form H2, right? Oxygen, when it combines with one atom of oxygen, you will get oxygen O2. And you know, O2 is formed from the same atoms. Hydrogen is formed from the same atoms. So element is something that is formed from the same atoms. Got it? So element from the same atoms that cannot be separated, as they are formed by chemical reactions that are difficult to reverse. So when I'm talking about a compound is a complex form of a molecule that is formed by joining different atoms in a molecule. I hope this is clear to you. Okay, no, ma'am, I know. Yeah, sodium chloride and water. It can be homogeneous if both of these can be mixed, right? Sodium chloride is a salt. Yes, that is a homogeneous. Homo means same, hetero means different. So homogeneous mixture that can, in which particles can be mixed completely. Heterogeneous means in which particles can't be separated completely. Like particles will settle down. Okay, so I'll be just giving you this, we're gonna discuss later on. There's one, just solve this question. Yeah. Select the homogeneous and heterogeneous mixture from the following. You have to select. Salt solution would be homo or hetero? Would it be homo or would it be hetero? Yes, it is homo. Petrol and water, can petrol be mixed in water? Yes or no? Can you mix petrol with water or would it float on the water? Yes, it is hetero. Sand and charcoal. Sand and charcoal. Can you mix them together? Tell me. Sand and charcoal. So what is your answer? Petrol and water, no. No. Okay, alcohol and water. Now Aliana would answer it. Alcohol and water. Can alcohol be mixed with water? If it can, then it's homo. If not, then it's hetero. Homo, yes, very good. Air dissolved in water, like oxygen dissolved in oceans with water. What about that? But you know, oxygen is dissolved in water. So how can you say it's hetero? It is being dissolved with water. So what about it? Homo or hetero? See, if it would be hetero if it can't be mixed. But you have seen that oxygen is dissolved, and you know there are so many water animals that are using that oxygen. So would it be a hetero or would it be a homo? Homo. Fruit juices. Fruit juices. What about fruit juices? Can they be mixed? Yeah. Yes, homo. What about mist? Just make a guess. Would it be homo or hetero? Mist. It's a liquid in gas. Just take care of that thing. Would the particles be mixed or not? You have to be sure. Next, we have why do petrol and water form a heterogeneous mixture? Because you can see the constituents separately. You can see the layer of petrol on the top and water separately. They can't be mixed with each other. So that's why petrol and water will form a heterogeneous mixture. So select an incorrect reason for separating components of a mixture. Just choose out of the four. Which one is incorrect? First, to separate two or more different but useful components, to remove undesirable and useless components, to remove pure or harmless components, to obtain pure sample of a substance. Incorrect. You have to choose an incorrect out of it. Yes, what would be the right option according to you? Yes, right. Right. To separate two or more different but useful components, you have to tell me the right one. Undesirable and useless component is right. Remove pure or harmless components. To obtain pure sample, that is also right. To separate two or more different but useful components. So do you think fourth one is not right? What do you think? Or third one? I'm waiting for your replies. Third one. Okay, students, so that was all about the demo session today. Okay, I hope we would be doing more productive things, solving more worksheets and solving a lot of questions, discussing many interesting things in the future, right? And I really like your interaction. I like Sonak, how he responded very well throughout the session. So I really liked that thing of him. And Ileana, she joined late, but yeah, somewhere she replied, but I was expecting her to join on time because she missed many important things. Muhammad might be facing some network issues, and others have left due to network issues. Okay, so we will meet in future. I hope we'll meet. So have you understood everything? Whatever we discussed, just let me know. Have you understood? Yes. Okay. Okay, so students, bye-bye. Take care of yourself and keep on practicing the questions and prepare well. Okay, bye-bye. Bye-bye.